Hey everyone. So we're going to build on this stuff from Friday. We were talking about s'mores, and using the s'mores, you had like a certain recipe that you had to follow, where you had a certain amount of each ingredient that you needed to have in order to make a single s'more. And so if you happen to have run out of an ingredient, then that was the limiting ingredient, because you could no longer make any more s'mores once you ran out of that. Anything else that you would have had left over would have been considered to be the excess ingredient. So you had that left over, but you were unable to keep on making more s'mores because you did not have enough of whatever the limiting was. So the same thing happens in chemistry, where we have some parts. We might have some kind of one of the reactants run out first, and as soon as that reactant runs out, then the reaction can't keep continuing, and so we end up with the reaction stopping, and that ends up limiting the reactant. So that's why we call it the limiting reactant or limiting reagent. And then whichever one is not the limiting one is going to be the one that's going to be excess. So let's just take a look to see what something like this would look like here in chemistry. We've got 2.00 gram times 10 to the 2 grams of lithium, and we've got that reacting with 2.00 times 10 to the 2 grams of oxygen. So the same amount of each ingredient are reacting, but because these might be used in different ratios, then it doesn't necessarily mean that there's not going to be something that's left over. So the first thing that we need to do in anything is we need to just write a balanced reaction so that we have an understanding of what those ratios are. So we have lithium, and we know lithium is reacting with oxygen gas. And since I've got two reactants here, chances are this is going to be a synthesis reaction. And I'll put a little 2 there since oxygen has a charge of 2. So what I need to do now is make sure that I am balancing this, because it is important to make sure that I have the same amount of each element on each side. So if you do not already have a balanced reaction, step 1 is always going to be to balance. Make sure there's a balanced equation there. Okay, and then we always talk about the main thing that we do, and what was on that mind map as well, is we are starting with grams, but the only way that we can make a comparison between two different compounds, or an element in a compound, is if we have moles. So in reality, when we say 4 lithiums reacts with 1 oxygen to give us 2 lithium oxides, we're talking about 4 moles of lithium, 1 mole of oxygen, and that has a ratio to 2 moles of lithium oxide. So we need to get this to moles so we can make a comparison in between them. So our first thing is going to be to find, so step 2 is going to be find moles of each substance. And we need to find the moles of each of the substances or each of the reactants, because we want to figure out which one is going to be running out first. So we're going to be starting with so our moles of lithium are going to be equal to 2.0 grams times 10 to the power of 2. And we're going to divide that by the molar mass of lithium. So I'm going to do 1 mole of lithium here and 6.9 grams per mole of lithium. Okay. That's going to give us an answer of 28.9 moles. Okay, so we have 28.9 moles of lithium. And for our other one, we have, so the moles of oxygen gas, so we have the same start. Sorry, I keep on putting the grams there. 10 times 2 grams of O2, 1 mole over, and since we have 2 grams of oxygen, we're going to have about 32 grams, just because we've got 15.9994 times 2. So we've got like 31.9988 grams for oxygen there. Yep. And then so we end up with we'll say 6.25 moles of oxygen 2. Okay, so we found out how many moles we actually are starting with for each of those different compounds. And now our next step is going to be that we're going to try and figure out how many moles our starting amounts give us of the product. So, I mean, we'll look at an example where you can compare it to the other reactants, but comparing it to the product, since we want to find out how much of the product will be created, really helps. So in order for us to find out the number of grams that we're going to be having of our lithium oxide, we can set this up. So if we're looking at from the amount that we get from lithium, so we start out with 28.9 moles of lithium. And this is why it's really important to make sure that you keep your compounds and your units in there, just so they can help guide you. Now, since we are at moles of lithium and we want to move to moles of lithium oxide, we're going to be putting 4 moles of lithium at the bottom, so we can cancel that out, and then 2 moles of lithium oxide at the top. We're also going to take a look to see what the molar mass of lithium oxide is. So we can plug that in and just take a look at lithium. So we've got 2 lithiums, 2 times 6.941 plus 15.9994. Okay, so we end up with 29. So 1 mole of lithium, 1 mole of lithium 2 oxide is going to have, my apologies for my error there, 29.8814 grams. So this is the molar mass. Okay, and then just going through, always want to make sure that our compounds and our units cancel out. We're just going to multiply all of that stuff together. So we have 28.9 times 2 times 29.8814. Okay, so we end up with 431.78623 grams of lithium oxide that would be created by this. We're going to find out the mass of lithium oxide. So keep in mind that this was from lithium. We want to find out the amount that would be created from the oxygen. So we're going to start here. We're going to do pretty much the same process, but we're going to be using the amount that we had from oxygen. So we have 6.25 moles of oxygen. And for every 1 mole of O2, remember this comes from our balanced equation up here. So for every 1 mole of oxygen, we have 2 moles of lithium oxide. Multiply that by the same thing. So this step is going to be the exact same, where we've got 1 mole of lithium oxide to 29.8814 grams. So that's our molar mass. And multiplying that through. So you can probably already tell that we're probably going to have oxygen be our limiting reactant. Yep, and our answer for that one is 373.5175 grams of lithium oxide. So looking at these two numbers, we can see very easily that this one's the smaller one. So that means that oxygen is going to be the limiting reactant. Usually it's nice to put like a little paragraph here or a sentence here. And so we're going to be making only 373. And since my lowest, if I'm looking at my significant digits, my lowest number is 3 digits here. I'm going to take a look over here, and that's a 5. So that means I'm going to be leaving it at 374 grams of lithium oxide is produced. Okay, so that allows us to take a look to see which one's the limiting reactant and how much it gets produced. The other thing that we're going to do is we want to find out which compound will be in excess, so that we already know that the lithium is going to be in excess, and we want to see how much is going to be in excess. So in order to do that, we can make a comparison between the different reactants. So this is all A, this is all B. Okay, so if we want to find out how much of, if we know that oxygen is a limiting reactant, we want to figure out how much of lithium do we actually need to react with that amount of oxygen. So we're going to be doing, could do this. So we'll look at the amount of oxygen. So the mass of lithium is going to be equal to, we're going to start with our limiting reactant here because that's the thing that finishes all up. And we just want to see how much of lithium we need to react with the amount of oxygen that we have. We're going to be putting down, so we have 1 mole of oxygen for every 4 moles of lithium. And then just as before, we're going to make sure that we have our mass up here. So we have 1 mole, so our molar mass, and the mass of lithium is 6.941 grams. Our units and our compounds cross out, and so that means that the mass of lithium that we actually need to create, or we need to react with oxygen, will be so we have 173. So the amount of the mass of lithium that we actually have, okay, so the amount of lithium we actually have is, we've got 28.9 moles of lithium. And then we're just going to do that straight up, just our molar mass, 6.941 grams of lithium. Okay. So we do 28.9 times 6.941, and that's going to give us 200.5949 grams of lithium. So this is how much we actually have. This is how much we actually need. And then so all we have to do in the end is subtract. So if we're looking at the mass of lithium in excess, it's just going to simply be 200, and I'll round this up to 3 decimal places here, or 3 significant digits, just because we've got 3 significant digits in here. So I'm going to make that, so just makes it easier for our calculations. There we go. I'm going to make this one 201 grams of lithium minus 174 grams of lithium, and that gives us 27 grams of lithium. So we have, I'm running out a little bit of page here, but therefore there are 24 grams of lithium available, or in excess. Okay, so I know that there's a lot of steps there, but I want you to just pay attention to the fact that this is the same thing that we've done already over and over again. So first we've got to balance the equation. So we are making sure that we can find the proper ratios of each compound. And then we're always going to find the moles. So when in doubt, find the moles. And we need to find the moles of each of the different reactants so we actually can compare them. Once we find the moles of each reactant, then we can go through, and then we're going to find out if we have this number of moles of lithium, then how many grams of our product are we going to create. And we set this up in the same way, just using our units to guide us, where we have the amount of moles that we start with, and then we use our ratio that we get from our balanced equation, and we use our molar mass so that we can change it from moles to grams, and then we figure out how much lithium can create. And then in our second part, we do the exact same thing except with oxygen. How many moles do we have? What's our ratio from our balanced equation? Here's our molar mass to change it into grams. And then whichever one is going to be the smallest one will be your limiting reactant. And that'll also tell you how much of the product will be created, because once we produce this amount, and this should be, as we said, 374 with significant digits. Once we create this amount, then all of the oxygen's used up, and so no more reactant happens. And then in part B, we just wanted to find out how much lithium did we actually have left over. So if this is the amount of oxygen we start with, instead of comparing it to the product, we're comparing it to the thing that it's reacting to. We use the mole ratios just like we did above. We use a molar mass just like we did above, so that we can find out how many grams of lithium we actually need to react with the amount of oxygen that we have. And then we find out, just like we did kind of like up above here, we go through, we just find out how much lithium do we actually have, and then subtract what we have, subtract what we need from what we have to find out what we have in excess. So there's a lot of steps down there, and we'll try this, we'll do some practice again with this tomorrow, but please try this out today so you can get a sense of what you're doing, and we can go to any questions that you might have afterwards.